Hello, students. We had a question come in about a concave kite. So it looks like probably something like question 14 out of the homework from 12.3, something like that. And so probably about, kind of, we know it's a kite. Can we prove perpendicular? And they have up here kind of make conjectures concerning these, but the idea is, remember, the diagonals of a kite are perpendicular to each other. But really, when you think about diagonals, sometimes you might be thinking just about the line between P and Q. And so what we're really referring to is the line, not the line segment. So if you are looking at the diagonal and thinking the diagonal would just be P to Q, you're not incorrect, that that's the diagonal, but the diagonal is also part of a line. And so when we have a concave shape, we would say, okay, it's the line is perpendicular to the other diagonal line. But again, this diagonal, the second one, doesn't even lie inside the polygon. It's outside the polygon. So really, it's connecting opposite vertices with a line will be perpendicular, and it will bisect one of them, the one that's not an angle bisector. So, and let's see here. Okay, so let's try, let me delete this. So if you're trying to show that these are perpendicular, let's just go through some of the pieces you should be able to pick up pretty quickly. First off, PQA, that triangle, is going to be congruent to P to Q to B. And we can see that because we have side, those are given to us because it's a concave kite. And lastly, this one is given to us because it's reflexive. Okay, let me get a little bit of white space here so I have a little bit more room to work. And jump back in. So what do I know? Triangle PQA is congruent to triangle PQB by side, side. Then what do we get? We get a bunch of stuff for free, right? I get this angle is congruent to this angle. I get this angle up here is congruent to this angle up here, right? All of these things for free. Okay. So all the angles are congruent, which is great. Now, when I come down to the bottom, the issue it looks like is I'm trying to show perpendicular down here, which means I actually need AQC and BQC to be congruent triangles. Okay, so let's draw them separately. Again, as I said in class, it's sometimes easier to draw them separately so you can kind of see the components. We know this piece is the same as that one. And again, that's because of the, oops, I almost labeled that Q. I need this to be A, Q, C, and over here, B, Q, C. So we know those are congruent. We know QC is congruent to itself, right? And then lastly, we need an angle or another side. Well, we're not going to get a free side out of this one, okay? Unless we come down and make triangle PCA, which we could do because we have the side, the angle up top because of this, and then the side PC is congruent to itself. We could do that. That would give us the sides. So you can do that. I think it takes roughly the same amount of work as this one. And what I want to say here is if you look at this triangle that kind of went like this, and then there's a triangle underneath it, those form a supplementary pair. So the angle on one side is supplementary to the other angle, right? Well, if you look in this shape right here, we have that in two different places. We have congruent angles that are marked as purple, and then we have their supplementary pairs down here, which means those two supplementary pairs have to be congruent. Now, if you want more of a written explanation as opposed to verbal, we could label these as X and Y, and we know these two are congruent, and we could say Z over here because we don't know what it is, and we would have to say, well, X plus Y is 180 because supplementary, and X plus Z equals 180 degrees because they are supplementary, okay? And then if you just subtract x off of each side, this becomes y is equal to 180 degrees minus x, and z is equal to 180 degrees minus x. And this becomes then the transitive property. If y is equal to 180 minus x and 180 minus x is equal to z, then y is equal to z. And that's why the two angles are marked here. So now you'd have side angle side. And once you have side angle side, you can conclude that this piece is congruent here. That would be that the diagonal is bisected. And lastly, that this angle, which I'll make as an orange blob, is going to have to be congruent to the angle next to it. And these two are also supplementary. And if they're supplementary and congruent, then we have really like, I already used x, I'll use something else. M plus M equals 180 degrees. So M has to equal 90 degrees. And that's how you can show they're perpendicular and that it bisects the angle. Very cool. So very similar. Again, notice what I'm doing. I'm just building triangles. Let me clear all these off because I want to say that, I think maybe the hardest part here is this would be a two-step process. It would have to be a two-step process because we don't know this angle up top is congruent to the one next to it. We don't know that. Okay. So you can do it many ways. I did mention another way. So if you wanted to, you would still start with PQA. So this one right here and say, okay, that one is congruent to its counterpart right over here, which is PQB. And you'd say these two are congruent. And what does that give you? It gives you an angle that you didn't have initially. That gives you that this angle up here is congruent. Then, if you wanted, you could even do PCA, right? Is congruent to what? Is congruent to PCB. PCB. Isn't that a drug? Oh my God, math leading us to drugs. Let's see here. So, and then we would have the side. We'd have the angle we already mentioned, and then we'd have this third side would have to be congruent to itself by reflexive, and that would give you side angle side as well. I chose to do it for the small triangle at the bottom. You could do it for the larger, bigger triangle if you wanted to. Perfectly fine. Perfectly fine. Totally. It's kind of whatever way you see it, whatever way works best for you. All right, let me make sure I answered all of that. I believe I did, but let me just make sure. Diagonals lie on perpendicular lines. One is the angle bisector of two opposite angles and serves as perpendicular bisector of the other. So anyway, there you go. So again, the angle bisector came from that free angle we got at the top. That shows that one diagonal is an angle bisector. And then we showed perpendicular and it bisects the other. So hopefully that helps. Let me know if you have other questions. Off you go.